What's up, guys? We are here again another Thursday night, 11 p.m. Eastern Time. We're going to be talking acoustics. We've got Anthony Grimani. How are you doing, my friend?
I am doing great, thank you. Can you hear me?
I
Yes,
hear you
sir.
just fine.
Okay.
Anthony,
Okay.
before I introduce Don, you remember I told you last week I was going to get back at you?
Uh-oh.
I got
What's it
back
gonna
at you.
be?
I
What's
got
it gonna
truffles,
be?
all gourmet
Chocolate.
truffles here. I'm going to be eating them while we're talking. You're going to have to
No.
live vicariously through me.
No. That's really sad, man. I'm actually not anywhere close to a truffle. I'm actually on site finishing a calibration, so chocolate, truffles, coffee, all of that stuff far away, far
I'm
away.
going
No
to do one.
cognac, nothing.
I'm doing one with chili with it's a hot one. You see the red flakes on it?
Man,
Yeah, this is
you're a bastard.
this is going to be good. And we got Jackson
Jason!
Done from HD 2020. He's going to add some installer perspective to the whole equation. How are you doing, Don?
Thanks, man. Appreciate that.
All right.
All right, eat your chocolate.
Oh yeah. I like that. I like chocolate and spice
This
go
guy
really
right
well
here.
together.
This guy right here. No, I do, dude. Actually, it really does. The pepper with the chocolate's amazing.
Okay,
All
guys.
right.
I hope I'm
All I got is some water. Okay.
at least you got Fiji.
It's got bourbon and Coke, so
So we're going to be talking about diffusion, and you wanted it to be called diffusion
diffusion.
because there's a lot of confusion about diffusion.
Wasn't that a band in the 70s?
I think so. Progressive rock band, right?
That's right. That's right.
Great name for
Yeah,
a punk.
there's definitely a lot of confusion or diffusion, and actually, too much diffusion can create confusion, as some of our well-known friends on the Harman Research side have written about. Actually, at the time at the National Research Council. So, what we're going to talk about diffusion scattering. What is it? Why do you use it? Where do you put it? And all that fun stuff.
Awesome. So I'm going to share the screen for you. You got a slide presentation, I guess we're going to be going over.
Yeah, I'm always sliding around. Let's see if I can get this to start. It tells me that my computer is not happy. There we go. Okay.
Wait a
So
second.
can you see this?
No, I don't have it's not up for the share yet.
Yeah. Anthony's on site on a job, by the way, everybody. So he's jumping in on this as he's working.
So let's see. Yeah, I the homeowner of this place was expecting for me to be done now, and he was going to be watching a movie now. It's like, well, I'm not quite done, and I got to do a webinar, so come back in an hour. He's like,
And I hear like asteroids in the background or something. You guys playing Atari 2600 back there?
no, not over here.
There's definitely some interference coming from your end, Anthony.
Uh-oh.
Yeah,
How
it
do you
sounds
like
like
that?
it sounds like asteroids.
Interesting. Not sure where that's coming from.
Ass.
No, not asteroids. The ones where they march down and you have to shoot them and you have the shield. What is that called?
Galega.
Missile command, right? No, not missile.
Defender or
It's all a blur at this age, man.
You still hear it?
Yeah. No, it's
Weird.
better.
Oh, okay.
It's better. It's better.
Interesting. I'm wondering where that came from. It's complicated, right? Maybe it's my phone ringing.
It could be your phone, yeah, for some
yeah,
5G
turn it off.
radiation.
Yeah, there we
Space
go.
invaders, thank you.
Space Invaders.
Thank you. Why couldn't I remember
Or the
that?
Tiger coming through.
My favorite back then was Astro Smash on the Intellivision, man. I used to go crazy when that would come on. Oh, I was quite the Astro Smash guy.
Okay. Can you see my screen now?
Yes, we are good.
Excellent. So,
My dad had
So that-
asteroids so bad he couldn't sit on the toilet. Oh God. Moving on.
should have left that one alone.
Rosenberg with the funny.
Crazy. All right, Gene, what do you want to know about diffusers, confusers, refusers?
Okay, so we talked a lot last episode about absorption.
Yeah.
So the antithesis of absorption, I guess, would be diffusion, right?
It is. Let's just call it a companion rather than an antithesis. Yeah, it's a companion. So Let me go to this slide, and then we'll bob back in and out. I'll just say that a well executed listening room, uh, listening just 2-channel listening room recording studio should really have a combination of absorbers, diffusers, some reflection surfaces, all strategically located just the right amount. And if you do that, you get to nirvana. So let's talk about that. So I always like to kind of come back a little bit, take a few steps back, and keep talking about why we even do these sessions. And it's because, warning, room acoustics will mess you up. You can get the best speakers, the best amps, the best cables, the best seat, the best beer, the best chocolate. And if the room acoustics are not good, your chocolate is not going to taste good, right, Gene?
That's true.
It's proven. It's proven.
Yeah. Oh yeah.
And if it's not proven yet, Gene and I are going to do research on this. We're going to
We'll have to do taste tests for sure.
Taste tests. It's going to take about 2 tons of chocolate, and at least 50 to 100 listeners. Anybody who wants to join in, please volunteer. So I talked about this 2 weeks ago, that reflections can cause distortion, not always, but they can be equal to distortion, and that the treatments, just like a medical treatment, the acoustic treatment for reflections is the right type of absorption, the right location that sucks out the sound reflection, or the right type of scattering, also known as diffusers, again, in the right location. So there are folks who think that, hey, if reflections are distortion, why don't you just get rid of all the reflections and, put just tons of absorption everywhere? That's not good. You don't want to do that. Humans expect some reflection, and killing all the reflections is bad. BAD. Don't do it. And what happens is your brain literally goes into like, whoa, what's going on here? I don't get it. I see walls. There should be some reflections. And if it's all dead, and you go into this this deprived mode, really, psychoacoustically, can't do it. So you need to have some reflections in the room to support the speakers. They just have to be at the right time in the right place. So as a reminder, what are we trying to do with the sound field coming back from the room? We want to hear some direct sound from the speaker, and we want that to be followed by a nice, even, smooth immersion of reflected energy around you. It can be actually expressed in direct to reflected energy, although that's difficult to calculate and difficult to measure. And most times it's expressed by how long the reflection hangs in the room, also known as reflection decay time in small rooms. It's not really reverb, it's decay time. And that tells you how much the reflection's there. Most of the rooms we're all working on should have a reflection decay time of somewhere about a third of a second, 0.3 seconds. So as a reminder, to get to that 0.3 seconds of reflection decay, the recipe is to apply about 15, at most 20%, but usually 15% of absorption surfaces around your side wall, your back ceiling, maybe a little bit on the front wall. And then apply 15 to 20% diffusion, also strategically located. I like to interleave it with the absorption, and I like to use what I call hemi-disc 2D diffusers towards the front of the room and 3D hemisphere diffusers towards the back of the room. We're going to talk about that today. The result of diffusion is it improves the sense of spaciousness in the sound you're listening to. And sort of philosophically, there's some elements in the music or the soundtrack you're experiencing that you want to hear very precisely, just like very clearly located. And then there's other ones that you want to have immerse you, be really spacious, and a diffusion helps in getting there. So let's talk about scattering and diffusion. So scattering is the concept of taking the incoming sound to a surface and scatter it into different directions. There is actually in acoustics a differentiation in the terms between scattering and diffusion. If we have time, I'll get to that later. Just for now, let's just call them kind of the same thing.
So I want to interrupt you 1 second, because this is a question that just came up, and we'll probably get to revisit this, like with you, me, Matthew Pose, and even if Don wants to join in, he could be the Brady Bunch. Why are the sidewall treatments not mirrored? We talked about this last time, and you actually caught me off guard because I've never seen anyone asymmetrically treat sidewalls before. And
right.
You have a lot of experience in doing actual theater rooms where you've actually found you prefer the spaciousness when you don't do it mirrored. Is that correct?
Yeah, let's talk about that at the end. I'm about to get into diffusers. Somebody's asking about why chocolate with just no milk is good. So pause,
okay.
Put that on hold. We're going to get back to that. And just like I will say, just like all kind of guidelines in acoustics, it doesn't always work. Things are complicated. The human listening system is very, very complex, very nonlinear, and things that may work in 3 rooms may not work in the 4th room. But generally, I do find that an asymmetrical direction, or not, I shouldn't, let's not call it asymmetrical. Let's call it slightly different between the 2 walls. And later we'll get into that. So again, the concept of scattering is to break up the reflections from the side or back wall or the ceiling floor. I'm just showing the side walls over here only. So do not absorb the reflections is what a scattering device does. It preserves the sound energy in the room, just broken into smaller pieces, more of a free field kind of character, more like a mist of sound. So scattering materials can be purpose-built panels. There's a lot of different companies that make them. They can also be the stuff you may put in a room if it's not a dedicated space, like a bookcase, furniture that has broken shapes, anything that's not a straight flat surface that's going to have a certain shaping to it is going to scatter sound reflections. Ideally, what you want in a good sounding room is a even trail of reflection. If you take a room and you just put some absorbers and have some what's called specular reflections, some hard surfaces, you may end up with a pattern like this over time. So the first bar over here could represent the impulse of the first sound that's going from the speaker to you. And then these other bars could be a reflection coming later. So imagine this was a representation over time of an impulsive sound like a hand clap. Then you could have a gap and then more reflections and then a gap and more reflections. And what's happening is your head's getting hit with all these distinct little reflections from everywhere. And that would be like sleeping on a bed of nails, not very comfy unless you're practicing yoga. Ideally, where we want to try to go is to smooth out those reflections, and a scattering device can do that. It takes some of the energy and redirects it around so that you have a nice even trail of reflected energy. So that's kind of the direction we want to go in. So how much scattering? We want enough scattering surfaces to smooth out the sound field. What does that mean? I'll get to it later. Big mistake people sometimes do with scattering devices is they make them too thin. I actually see some panels out there that are 1/2 inch or 1 inch thick. So that's like 1 to 2 or 3 centimeters. That's not enough to do a good job. They really need to be 6 to 12 inches, which is 15 to 30 centimeters thick, so that the wavelengths we're interested in actually get affected in terms of scattering. So how much, where? Well, a good first guideline. I want to pause again. The purpose of these webinars is not to turn you guys into acousticians. That's a 4, 6, 7 year field of study. It's more to give you a taste for what you got to worry about with acoustics and some just really rough overall guidelines that if you follow them, you're gonna vastly improve your sound quality. So, how much diffusion? Put about as much as you have absorption. Where do you put it? Well, interleave it with your absorbers. That's a good first approximation. So mix the scattering with the absorption. And ultimately, I do want to say that diffusion is the stuff that high-end rooms are made of. So a room that has good speakers and just a few absorbers hasn't quite yet achieved really high-end. If you put some diffusers in there, you'll just notice an enormous difference, enormous. And that's been known for, 30 or 40 years now. This is not new data. So good scattering devices can avoid flutter echoes by redirecting them rather than absorb them. So if you have parallel surfaces in a room and you don't want to over-absorb the room, you can get rid of the flutter echoes with good diffusers. And what's interesting is diffusers actually make absorbers work harder. So if you have an absorber panel over here and there's a scattering device over here, without it, the sound from your speaker may have avoided it, may actually not find it. But a scattering device over here can actually scatter the around so that it finds the absorber. So I generally find that a room with just absorbers has a reflection decay time of something. You start putting diffusers in there and the overall decay time goes down, partially because the scattering devices do a bit of sound, but also because there's more mean average free path that finds absorbers out there. So diffusers keep the aliveness in the room. They make the room be smoother. They help the absorbers work. But too much of a good thing is not good. So you could say, hey, if diffusers are so great, I'm just going to buy a whole bunch. I'll put them all the way down the sidewall, the back, the ceiling, everywhere. No, that leads to confusion. And there's a bunch of experiments done on that, and people have generally said, no. It's interesting, but it's not really the right sound. All right, let's get geeky. By the way, a bunch of these slides come from a CEDIA or ISE presentation I've done the last 2 years that come from presentations that are sourced from, I think, Dr. Floyd Toole originally. I kind of lose track, but I think this is a slide diagram from Floyd Toole. Anyway, this shows real measurements. This is what's called an impulse response, or a time-based result of impulses played in the room. This would be the direct sound from a speaker. These would be reflections from the sidewalls, the ceiling, and then other reflections. And you can see that the sound energy floating around the room and hitting your head is sort of chaotic. It's going up and down and up and down and up and down, and you're trying to listen to music in there. Meanwhile, you're just getting slapped all over the place. Here's a room that you've put some diffusers in. There's an initial sound. There's some absorbers would have gotten rid of this initial time delay. And then you have this relatively smooth decay. It's not a perfect line, but a relatively smooth and even diffusion in the room. That sounds good. Bottom line is, people who listen in there are going to go, this is pleasant. I like it. So, reflection versus scattering. Here's a diagram also from, I think, a Floyd Toole presentation. A flat surface will just reflect the sound. If you had thought of sound as a vector that bounces off the flat surface, it'll right back up. A scattering surface, or one that's broken, the sound will just break into little pieces. And that all depends on the wavelength. So wavelength is an expression of how long a sound wave is. Bass frequencies have really long waves, 20 feet long, for example. Mid frequencies have waves that are 1 foot long. High frequencies have waves that are 1 inch long. And depending on the shape of your scattering device, it'll diffuse more or less of the lows, the mids, the highs, and this diagram kind of shows it. I got another one that's coming up. So sound, in the case of this diagram over here, sound with wavelengths that are of about the size of these bumps and dips and bumps is going to get scattered. So how big does it need to be? So ideally, you want your diffusers to be at least 8 inches thick and up to 12 inches thick. And there's a little note here that may be challenging in the real world. So if you're building a multi-purpose room where one day you've got your friends over to, have some drinks together, next day you're playing video games, next day you get you and your family enjoying the space, it's hard to put big diffusers in there. Just be realistic. In most of the designs I do, the diffusers are between 4 and 6 inches, just so as to not take up too much room out of the space. Behind me, actually, I'm in a theater right now that, like I said earlier, was calibrating. Behind me is actually stretch fabric. Behind that stretch fabric is absorbers, diffusers, and speakers, in this case, the side surround speakers. That stuff all fits in about a 4 to 6 inch space.
So does adding an air gap behind a diffuser work similarly to when you do that with absorption, or it doesn't help at all?
No, not really. Yeah, with an absorber, it helps, but in a diffuser, it doesn't really change things too much. Mm-hmm. So to explain just more viscerally this business of small diffuser, big diffuser, what does it do? Imagine a pole, like a post, that's 20 centimeters, in other words, 8 inches. This presentation, I'm realizing the last time I was at IASE in Europe. So imagine a pole, 8 inches, 20 centimeters. Imagine a 100 hertz wave hitting that thing, 100 hertz, 10 foot wide. 100 hertz wave is just going to wrap around that 8 inch pole, that 20 centimeter pole, as if it wasn't even there. Just like if you're driving over a penny with your car, you don't even know it's there. A 10 kilohertz wave, which is 3 centimeters of wavelength, is going to reflect right back off that pole, because the pole's about this big, the wavelength is this big. That pole is going to actually be maybe a slightly redirecting, but basically a reflector. A 1 kilohertz wave, which is a foot, 30 centimeters, hitting a pole that's close to the same size, is actually going to scatter off it, because the wave is about the same size as the surface that it's on. It's just going to go bing, and it's going to get scattered off. Got it? Make sense?
Yep.
So a high frequency signal is going to bounce off a curved shape. A low frequency is going to go around it. A mid frequency is going to be affected by a pole that's around 8 or 10 inches wide. So now imagine a 2 centimeter pole, a 1 inch pole. Well, it's not going to do anything at low frequency. It's not going to do anything at mid frequency. It's going to do something at high frequency. So most diffusers work over a certain range of frequency, unless they're one of these complex nested diffusers that have a whole bunch of different shapes in them. And what frequencies do you want to treat? Is it useful to treat really low frequencies for the sense of spaciousness?
No.
Very little.
Yeah.
Very little. The human listening system really pay attention to really low frequencies in terms of spaciousness. Is it useful to treat really high frequencies? Very little. It used to be thought that high frequency needed to be diffused. It's been found in research in the last 20 years that really, and that's because yours are far away enough from each other that they can't really tell the differences between the scatter here and the scatter there. So the main region where we want to treat energy is between 500 hertz and 2 or 3 kilohertz. That's really where it's useful to do scattering. And, from this little discussion, it means the shape and depth of the diffusion elements needs to be somewhere around 8 or 10 inches, which is 20 to centimeters. Or 20 to 25.
You're cutting out a little bit, but just to recap, it's interesting with the last two webinars that we've done. The old school thinking of like absorbing the entire room and just killing high frequencies is really out now. If you think about it, you're trying in both cases, whether it's absorption or diffusion, you're trying to preserve those really high frequencies. Like we're not just trying to suck those up like we were back maybe 20 or 30 years ago.
Yep, exactly. Can you hear me now?
Mm-hmm.
Okay.
Yeah, you're cutting in a little bit, but it's okay.
All right. Yeah, you're completely correct. And where that comes, just much more recent research, listening tests in small room acoustics that show that, the region of interest is different than what we used to think of as just the high frequencies. So leave the high frequencies alone. They're fine. Don't bug them. Just the mids. So continuing on that. So diffusers will attenuate reflections, not by absorbing them, but by scattering them around. Engineered surfaces, which is things that like this. This is a quadratic diffuser with another quadratic diffuser inside it, using really interesting equations. I guess I don't really have time to get into, but anyway, so that a box like this would want to be 8 or 10 inches deep, and a geometric shape like be all the way up to 12 inches, so 30 centimeters, big. And if somebody's putting diffusers on the wall that are really skinny, it's really not going to do very much. So, what I'm calling in this presentation engineered surfaces is stuff that somebody's designed based on math and based on modeling, and that is a panel you put on the wall that's got really interesting shapes or ugly shapes, depending on how you feel about it. The better ones work amazingly well. I'm showing you here a diagram of what would be a diffuser with a whole bunch of different depths and different shapes, and the energy that hits it scatters well over a broad range of frequencies. So it distributes the energy really broadly. That's what you want to go for if you're really serious about your sound quality. This used to be really common about 20 or 30 years ago. You don't see it so much anymore as what's called cylindrical shapes. So this is a continuously changing curve that region tackles a low frequency, and as the radius gets tighter and tighter, it tackles mids and highs. They work pretty well. They're often found in performance spaces, out of hard surfaces, plaster, concrete. You can use those in home cinemas. They tend to end up having to be pretty big and take up a fair amount of room. So semi-cylinders or shapes that are semi-cylindrical, they do work okay. You can make them yourself. So for DIYers, just getting a tube, bent plywood thing to finish good work okay. And they do provide some pretty good scattering. Here's a chart from a really good book by Trevor Cox and Peter D'Antonio. Great resource, absorbers and diffusers, by the way.
So are these hollow or would they be solid?
You would want to, good question. For diffusion, it doesn't really matter. But if hollow and you actually put a little and put the gap, it can become a bass absorber. So the inside of that could become a bass trap, a resonating bass trap. I'll cover that also later. But be careful. If one of them works really well at providing some scattering at the right frequencies, if you put two of them side by side, it almost becomes like a reflector again. So that's also kind of more recent info. I've seen rooms that have like circle, or pilaster of the curved shapes, and you want some space between them.
So maybe some absorb. I'm sorry, go ahead, Don.
Yeah, how do you just determine that space, Anthony, between those? Is there a
Yeah,
formula?
there's a point here where it always gets a little too mathematical. I would say if you got an 8 or 10 inch space, leave 15, 20 inches space, maybe put some absorption in there. I heard Gene kind of chime in on that, and that works. All right. Scattering processors. There's a whole bunch of different topologies in scattering. Most common one from the olden days is what's called QRD, quadratic residue diffusers. The quadratic residue is not an acoustic residue. It's actually the math that's used to calculate the depth of the wells is a quadratic residue equation. There's another set of equations called maximum length sequence. There's primitive root, there's optimized, there's hemispherical, there's complex curves. I'm not going to get into it, but if you go look at, on Wikipedia, there's a bunch of cool info that you can read about all the math and all the theories behind these. Most of these theories are mathematical, and they're based on pure acoustics. So what happens with waveforms, with actually wavefronts, with molecules of air moving around. They don't really address psychoacoustically what you hear of it. They just go, hey, if you feed a wave of sound of this, it's going to do that. Turns out some of these scattering devices have a certain psychoacoustic character to them. And a lot of work has happened in the last 20 years to get to places where the scattering character is smooth. And what we want is smooth, not something that may be zippery. So I guess sort of the venerable, the granddad of diffusers, of engineered diffusers, called QRD. They rely on high velocity diffraction. They are frequency selective, which depends on the depth of the wells. The better built diffusers have wells at different depths. So instead of having all the scattering at one frequency, you do a little less scattering, but you spread that over a range of frequencies. Some of them are nested with shallow diffusers inside bigger diffusers and bigger diffusers using fractal equations. But if you are in a smaller room, like the ones we typically, where you may be only 6, 8 feet from a wall, and you put too many of these, sometimes it can get a zippery sound of the sound because it kind of bounces off in repetition, and you hear on impulsive sounds, you hear this little zing. I've heard that in some studios where they line the whole back wall with diffusers, and it doesn't happen sometimes. Just beware about how many of these things you.
Anthony, what about those space arrays that Audioholics used to make that look like a checkerboard? They only went a couple inches deep, so those are mostly just a high frequency scatterer.
It's a scattering device that works over a specific range of frequencies. They were enough to do something in the sort of the upper mid range, not very well distributed over the frequency range. They do something, and it's a kind of an interesting thing to put in a room. It also has an aesthetic value that's relatively smooth looking. So you'll often hear me talk about the reality of the conflict between ideal performance and what it's got to look like.
Right.
It's not. These rooms are not just for us. So, a little more about QRD. Again, how it works. Sound that I'm representing here as a vector. Sound is not actually that. It's waves. But imagine coming vector. There is a frequency at that sound is going to resonate around that well. Eventually going to get amplified by that well. And right at the tip here, at the hard surface, it's going to out. So in one range of frequencies for this well, the sound, instead of bouncing off a hard surface, if there was a well there with no diffuser, is going to come back out, swing, scattered. And at a different frequency over here with a shallower well, the same thing will happen. At a different frequency here, different frequency here. And one of the things around QRD diffusers is how you arrange the various wells from low to mid to high to low. There's all kinds of math that you'll find on the internet and books on how to do that. And this is interesting. So part of what actually causes the sense of diffusion is the fact that the oncoming sound has a certain phase character. The bounces off the wall have a certain phase character. And when they resonate and scatter, their phase has rotated, and your brain interprets that as a business. So RPG, the first company to really put these things on the market back in the early 80s, stands for randomized grading. And that's the whole concept, is to randomize the phase of these things so you actually get the sense of smooth diffusion in the room.
So we're not even talking about any ceiling diffusion at this point, right? You're just doing all the lateral stuff.
Right now, I'm just talking about diffusers. What are they? Whether you have them on the floor, the walls, the ceilings. Later, I don't. We'll see how much time we're going to take today. But at the series of absorbers, bass traps, and diffuser for bass traps later, I am going to put this together into where I like to put them, where the books say to put them, where the generalized opinion on placement is. There are places on the ceiling where diffusers work really well and places where they're not useful. There's places on the walls where they're good and places where they're not. I will give you a little spoiler alert. Those great pictures from recording studios from the 70s that on which the whole back wall was all diffusers, not a good idea. That causes way too much confusion off the back scatter, not a good thing to do.
Well,
So
I kind of you, Anthony, on that with using, because in most of the theaters that we did, we always put diffusers on the back wall. But, your information on putting absorptive panels flanked by diffusers makes a lot of sense with dealing with the slap echo, which is one of the most problematic things that we deal with. So I found that very interesting. Yeah,
putting again, I'm kind of getting ahead of myself, but I think it's good to kind of go forward, go back. Spoiler alerts. The generalized consensus with those in the know is the middle of the back wall wants to be absorbed, and that's basically to reduce the amount of energy that's flowing back and forth in the middle of the room. Energy that flows back and forth in the middle of the room is hitting your two ears at the same time. It's telling your brain it's mono. Mono's all good, but we don't want the room to increase the mono-ness of the sound. So,
good point.
By essentially killing that evil axis of reflection from front to back by putting an absorber right in the middle, you get rid of that, and then to the outsides you put some scattering devices, some diffusers, and then you have energy billowing around, smoothly scattering around. That sounds better. So
right. And we've always thought of using diffusers in such a way to preserve that precious energy, especially for surrounds and back channels. Right. But adding that little bit of absorbiveness on it makes a complete sense.
Right. And you want to preserve the diffusion. You want to preserve is the stuff that's really flowing laterally, not front to back, but on the axis from left to right. That's known as to make things just sound better. So let's pause on that. Let's get into something else. Different manufacturers make diffusers. Different car manufacturers make different cars, but they all kind of agree to the definition of horsepower. So you can get a car that has 60 horsepower, small putt-putt. You're not going far, you're not going too fast with that, or you can have a car that's 700 horsepower, and generally that tells you just how much of this you're going to get when you push the right pedal, right? Same thing with diffusers, same thing with absorbers. There are coefficients, there are actually data points that you can look at and go, wow, this thing works better than this other thing. So there's a definition of diffusion coefficients and scattering coefficients. It gets kind of tricky. I will read you what it says. The scattering coefficient indicates how much of the incident energy is scattered in non-specular directions, specular being the mirror reflection. So scattering coefficient says how much have you broken up the sound. Diffusion coefficient tells you how uniform that is over directions and frequency. So what you want to spend your money on panels that have a high scattering coefficient and a really even diffusion coefficient so that what you're getting back from the room is really smooth. For more on this, read this document that you can download from the Audio Engineering Society that talks more about this than I would even have the time to get into. Here's some examples. So I'm going to keep bringing up our good friends at RPG. Hello guys from over there if you're listening. Hello, Peter. And here's, again, a venerable product. This has been around for a very long time. Great product called the QRD 734. And here's 3 elements of data on them. First, in red, is the absorption coefficient. Yes, sound energy that hits this is going to get absorbed. A really top-level absorber, one that fully absorbed, has a coefficient of 1, which means it absorbs 100% of the sound. This diffuser absorbs between 20 and 30% of the sound, depending on frequency, so not that much. Second thing here is the scattering coefficient in green. So at low frequency, virtually no scattering. as of about 500 or 600 hertz, because it's about this deep, some scattering that goes all the way up to 80%, which is good. Goes up and down a little bit. It's not completely smooth, but pretty good. And so that tells you how much of the oncoming sound has been broken out of being a direct bounce. And then the diffusion coefficient here shows that it's pretty smooth over this range of frequencies. It doesn't bump up and down. It's not super high, but it's even. So what you want is the highest coefficient you can get in scattering and the smoothest you can in the diffusion. So that's the RPG QRD 734. Now, more recently, the people at RPG have been experimenting and playing with other shapes, bicubic waveform diffusers that are these really complicated shapes that look like little wavelets. And here's some absorption, scattering, and diffusion coefficients of these things. So here you see the absorption's lower. Here you see the scattering coefficient is about as high, but you see how things are a lot smoother. So these are examples of shapes of things they've been doing. These do look at first like old school polycylindrical things, but they actually have continuous varying and very mathematically complex curves, and this stuff works really well. So what I say on here is curved diffusers, newer and more better. So the QRD style from the 80s works pretty well, has some side effects. The new stuff is curved shapes.
But that's a different application. That's for sound production, not sound reproduction, right?
Well, what's shown here, not shown here is pictures of a place with a big beautiful piano and stage. But in reproduction, same thing. What you want is your speakers. Again, there's a sound that goes right to you. Hello. There's a sound that goes right to you and the sound that's bouncing around the room. And what you want of what's scattering around the room is to be as even as possible in all directions and at all frequencies. So, however, or like on planet Earth, they would say, but these are just mathematical coefficients. So let's talk a little bit about the math behind all this. So what I call a 2D diffuser, which is I'm using a geometric character to that, not the QRD calculation of the D, but the geometric. I call a 2D diffuser one where the incoming sound gets scattered back out over what's called a hemidisc, half of a disc. Okay, so that sound that's coming in is one dimension, and then what's bouncing back is a plane, which is 2D. And in saying that, I'm not using the math in the QRD equations. I'm just talking about how it scatters the sound. I like these planar diffusers towards the front of the room so that the sound of the speakers is scattered back out without being sent up into the ceiling, without being sent into the floor. It just emphasizes the lateral energy and gives you this really nice open sound stage. Another type of diffuser is what I'd call a 3D diffuser, which is a hemisphere radiator. So a device where the sound that comes in gets broken up into half of a sphere because it's on the wall. You can't scatter around the back if it's on the wall. And I like those generally towards the back of the room, upper part of the ceiling, back of the room, back. What that does is it returns the energy from these quadrants ascending, and it just sounds more better. So what do diffusers look like? I've already talked about a few of them. This is a cylindrical shape. The sound that hits this is going to get scattered out evenly at the right range of frequencies, or generally what I'm just going to put in the category of slotted. So all these things that have different wells, that get scattered also only in 2 dimensions, right? You can see that the cylinder is not going to scatter the sound up or down from it. It's only going to be on this planar direction, right? And I'm going to do a quick mic check. Can you guys still hear me?
Yes.
Excellent. How am I coming through? Nice and clear?
Yeah, you're getting better, actually. It's not dropping out as much.
I'm getting better. Great. The bits are getting better. And then generally examples of 3D diffusers. Here's a device made by ART. You can see that this shape that's all like broken and all bizarre with these spikes that stick out. The sound that hits that's going to get heard in 3 dimensions. You can imagine. Whoa, microphone almost fell. getting too Italian about this. Can't help it. The name's Grimani. What do you want me to do?
Mic drop.
Mic drop. Okay. You can see that a pyramid shape sound that hits it would get, re-radiated in 4 directions. It's kind of a rough diffuser, really smooth. You can see that a shape like this that has all these pokes here, or inverted, these from RPG, would scatter the sound back out in 3 dimensions. Horizontal scatter, and horizontal and vertical scatter if it's placed on a sidewall. You get that? So, in full disclosure, I have a company that does a bunch of different things. We design and calibrate rooms. Right now, I'm in a room that we designed and it. And I'm shaking my hands around.
Drop the mic.
Mic drop. Can you hear me now? Okay.
Yes.
Okay, so we also make diffusers and absorbers. This is a diffuser we make that's a wood cylinder. It is hollow inside. There's some slots on the top and bottom. There's a little bit of material, and it is actually a low-frequency absorber. It works between 400 hertz and 4 kilohertz, and it has a little kick of low-frequency absorption around 150 hertz. You can see the slots here better. So that's a... Ask me, Gene, hey, do you leave these hollow? Well, you can put a little stuffing in there and maybe cover it with the right size of a slot, and you got yourself a wrap too.
So what is that fiberglass that's inside? If someone wants to build something themselves, you use fiberglass?
Yeah. So first off, don't overstuff it. If you overstuff it, it's not gonna work right. You can use fiberglass. You can use a little bit of rock wool. You can use a bit of polyfill, sort of like a dense polyester material, recycled cotton, whatever it takes. It's a fiber provide some damping. I wouldn't absorb more than 20% of the volume inside. And what the absorption
20%, you said? Your mic cut out.
Of the percent. So, and what the damping inside does is it actually spreads out the absorption so that this thing doesn't just work like an organ pipe at one frequency. You want a little bit of spread on that. All right. Here's another interesting product. It's actually a combination of an absorber and a diffuser. It's a chunk of dense foam with slats on it at different directions that scatters mids and highs and absorbs the kind of the lower frequencies. Kind of an interesting, if you can't put too many panels in a room, you have a little bit of both. And I think that the future of acoustical treatments will be much more in this direction. Devices that provide some absorption to damp out the room, some scattering to get to spread out the sound, rather than have to separate. It's a lot easier to work with. All right, here's another example of a diffuser. I'll put this in the slotted shape. This Sonatus line called the 4-fuser. It's a really cost effective. I think if I remember right, this thing is $5 or $40 in shipping. And it's a dense styrofoam with acrylic paint on it, and the shapes are. It's kind of hard to see on this diagram. How is this coming through to you? Do you get some resolution on this?
Oh yeah, looks good.
Okay, good. Another diffuser in our Sonatus line called the Bicubic. Bicubic is a 3-dimensional scattering device with these wells and spikes at all different directions. This works well from 300 hertz to 6 kilohertz. Very cost effective also. I think it's $65 or $69 with shipping. Very good deal. It comes in a bunch of different colors. This is a much prettier device, all wood, more expensive. Does about the same thing as this, just looks prettier on the wall. Weighs about 50 pounds of solid oak. There is a derivative of that made out of polystyrene, less expensive, works pretty well at the lower frequencies. This is going to work a little bit better because it's a solid material. So how it scatters the lower frequency sounds tighter than something that's a styrofoam. It matches budget. If you got a good budget to do things, you got expensive speakers, high-end amps, everything is really good, high-end decoder. Go for the generally from the different manufacturers out there, go for the deeper, bigger wood or solid materials.
So Anthony, we got a super chat here. I just wanted to see if you can answer this question real quick for MK. Yeah. The awesome presentation. What is the minimum you should sit from a sidewall QRD, second 2D prime, 7 diffuser? Is it 4 feet?
I think you need a little 4 feet. I would do 6 or 7. There's a fair amount of work on that. Actually, the paper by Sean Olive and Floyd Toole, actually the inspiration of that, called "About Confusion and Diffusion," does tackle that a little bit, and there's other resources in there, or there's other resources out there from other research. Know that what I'm spewing over here could sound like opinion. It's the result. I would say probably about 4 or 5 feet worth of paper I've collected over the last years. I actually have a big file cabinet in my office, like a 6-footer full of drawers full of papers. There's people who spend their time researching this stuff. I can't. I'm trying to run a business, trying to family.
Hmm.
I'm not an academic these days working in a university doing pure research. But the really cool thing is there's people who do that, either working for manufacturers or working for pure research academic environments, and you can go read their stuff. So type it in. I would generally try not to put people much closer than 5 or 6 feet from a QRD type diffuser.
Gotcha.
Okay, any other questions? We're into 45 minutes. We may actually end a little early today, or I can keep going. Tell me.
We could wrap it up because I think we pretty much covered most of what you want about diffusion. I think what we probably want to do in the next round is do bass traps. Everybody's waiting for the bass traps. I know you want to talk about reflectors too, but I almost kind of consider reflectors a subcategory of diffusion. Wouldn't you say that?
I actually don't know what a reflector is. A wall is a reflector, right?
Yeah.
And let's see. Should I stop sharing my screen? You took care of that already?
Yeah, I took that off.
Thank you. Man, what would I do without Eugene? What would I do? So I consider a reflector, it's a hard surface, and it's there already. Why do you have to add one? You could actually put a curved, a angled reflector to deflect the sound somewhere else. At that point, just put a diffuser and an absorber in the size rooms we're working in. In bigger spaces, it's a different story. And I call big spaces large venues. And by the time you've taken a large panel and turned it sideways, you're going to get some scattering off that. So you could actually call, I suppose, an angled reflector a version of a scattering panel. You're correct.
So I'm going to put you on the spot because I'm inspired by this comment here. Can you sum up everything about diffusion in a minute that we talked about today?
So here's what I would say. For best sound, not measurements, not for what goes on in microphones. By the way, I think I'm just going to take a quick opportunity to show you where I am. So this is a room I'm working in. This is actually a theater in Southern California. I'm actually in the middle of calibrating this. There's a screen, there's some microphones, there's a light that's like lighting me up. Sorry, hold on one second. Focus. There we go. So you do not see all the treatments behind here because they're all hidden by stretch fabric behind me. We'll talk towards the end when we get into, okay, how do you integrate all this in the room? I'll show you different ways to do that. But my 1 minute pitch would be, if you want a room like this to sound good and natural, and what I call good and natural is the dialogue's clear, the music is enveloping, the sound effects are both very pinpointed, and when they need to be immersive, they're immersive. You want the right combination of some absorbers and some scattering panels, also known as diffusers, so that you can actually break up the sound into a smooth mist of sound energy.
Right.
The concept of mist is interesting because, those of you who are starting to get into summer, or those of you who are in the southern hemisphere and in summer, know that it's really nice to have a mist of air, of water in your face. That's really comfortable. And the same thing happens to your auditory system when you have diffusion in the room. It's just this really nice, it's like this smooth lotion of sound energy, man.
So Anthony, what you're saying is you're actually out in a theater where somebody's paying you to professionally put it in versus just being internet educated and being a troll. So is that what you're saying?
The client, for the record, the client's not paying me right now. Okay, but this is
you learn all this on the internet and make a YouTube channel. You're an expert.
No, this is actually what I do for a living. Before my webinars, I'm doing this stuff. Often after the webinar, when we all hang up, I go back to designing or calibrating. This is what I do, man. This is my life.
So we got a super chat. I've never gotten a super chat like this before. A $200 super chat from John Lim. He's asked this question a couple of
I
times.
like 10 times. Yeah, I was like, yeah, help
Is
him.
it true that a rear wall diffusers are not advisable and an MLP is less than 6 feet from the rear wall?
Two-part answer to that. They're not advisable in the middle of the back wall. I actually like to call it back wall rather than rear. Long reason. I'll get to that in some other session. But middle of the back wall should be absorptive, not diffusion. Not diffusion scattering the energy right to the back of your head. To the edges of your back wall. So let's say you're sitting 6 feet from the back wall. Okay, let's say this wall, instead of being 2 feet behind me, is 6 feet. I think it's okay to put diffusers all the way over there. So on the edges, it's cool because the sound that's traversing you, sound from the left speaker that's passing and hitting over there is scattering scattering over there and bouncing around. It doesn't really come back. It actually has plenty of room to bloom and develop. So I wish these answers were always like yes, no. Unfortunately, there's always a bigger story. Don't put a whole back wall of scattering diffusers behind you. Not a good idea. Towards the edges of your back wall works fine.
Thanks, John, for the super chat. And we got one more from John Law. Says, are binary amplitude diffusers effective?
Binary amplitude diffusers. So you got me. I'll have to go research that.
I've never heard of that term. Yeah.
I know binary. It's the term amplitude that's getting me confused. So I'm diffused and confused. I'll look it up and we'll talk about it next time.
Diffusion
confusion.
So the only thing I want to touch on that nobody's even asked, and you're talking about putting diffusion not in the middle of the back wall, but on the sides. And we talked about this in my own room. What if you have back channels there? You don't want a diffusion panel next to a speaker because that's really going to muck up the mids and maybe a little bit of the high frequency response from diffraction of having that surface there.
Yeah, you very good point, Gene. So these panels are all a certain thickness. Again, absorbers should be 4, preferably 6 inches thick, and diffusers should be 6, 7, 8 inches thick. If you're putting them on a wall, I'm just noticing my finger. Yeah, I cut myself. I slammed myself with a hammer. I work, man.
Ouch.
I don't just geek out.
Yeah,
stuff.
Yeah, really.
Anyway, so all of these thicknesses of panels, the way I like to do this is the speakers are on wall, side by side with all the treatments. Look at it from the top. The face of the speaker is at the face of the diffusers and absorbers. And that's why I like to do rooms in which there's stretch fabric, everything is on the wall, not in wall. And then you don't end up with that problem of the scatter off the edge of the diffuser. But yeah, thanks for bringing that up. If you have in-wall speakers for sides, backs, tops, and you put diffusers right by them where the sound of the speaker is going to like graze off the diffuser, that's going to be a problem. So make sure you have a little room, maybe a foot or 2 feet between where the speaker's radiating out and where you put a really big, deep diffuser.
Gotcha. Good points. So, it'd be great if you can do a short article on this and I can link it up on Audioholics and then put it in the reference below, because people like to see illustrations. It's great doing all this talk, but if you have any articles that you want to start publishing on Audioholics, we could basically put those up and then embed the videos in there so people can go back and look at that.
That'd be fun. So the presentation has a fair number of slides that show where these things go. But an article would be fun. Love to do it.
Yeah. And guys, if you're a member of our Patreon channel, I have this entire slide presentation there. So you can go on our Patreon channel. You can reference that and you can go back and look at that while Anthony's talking about all the various aspects of this presentation.
Hey, Anthony, real quick, how many rooms you say a year that you do? I mean, roughly.
Between 30 and 40 a year. So, and I can do that many because I'm actually not building the rooms. What I'm talking about is rooms that are brought to us by an integrator, by an end user, by somebody. They want us to do the design, supervise the installation, maybe go calibrate it. So we're servicing up to 30 or 40 projects a year, and which is why over 22 years we've done close to 1,000.
Anthony, here's that thing about the binary amplitude diffuser. Maybe that will ring a bell to you.
A BAD panel. Sorry, I was like, yeah. So both RPG Kinetics and a few other companies are making those. So that's a chunk of an absorptive material with a panel on it that is perforated different patterns, and they do definitely provide diffusion, but usually only at higher frequencies. So if you look at the RPG BAD panel, it's interesting. There's back many years ago a conversation with Peter D'Antonio, and we started to talk about that. So he came up with this thing where the holes are at different places, and there in some places there's a large flat surface between the holes, and other places there's a small surface between the holes. Where there's a small surface between the holes, you can reflect just high frequencies. When there's a larger one, it reflects highs and mids. And where the two meet, that out of that change of phase between the different filter, you get scattering. That's how that works. If you go like, how do you get scattering out of that? It's just that the reflected energy has a different spectrum, a different frequency balance, depending on the size between the holes. So practically, they tend to only provide diffusion above 2 or 3 kilohertz, and below that, the sound goes through the holes and gets absorbed. And in a conference room where you're trying to get rid of high-frequency slap echo, that little zing that happens when you have a small room and the parallel walls, and you don't want that to just be annoying in a conference, whether it's regular people talking to each other or if it's on speakerphone or on Zoom. We're all on mics these days. It's good to treat the highs for that purpose. In a listening room, like I talked about earlier, we really want diffusion from 500 hertz to 3 or 4 kilohertz. So that's kind of right on the edge of where those BAD panels start. Kinetics calls them TAD, if I remember right, and RPG calls them BAD. They have their place. Personally, I don't feel the need for them in listening rooms or home cinemas. It just doesn't scatter at the low enough frequency to be useful.
So we got one more super chat here asking about what kind of treatment you should put between the main front speakers. And I'm going to basically answer that for you. And you tell me if I'm wrong. I'm going to probably say absorption in that case, because especially if you have like a screen, which is a big reflective surface. If you have an acoustically transparent screen, we talked about actually putting absorption behind that, right?
Yeah. You should put a lot of chocolate, if you're like Gene and I. Absorption's good.
Right here.
There it is. Absorption's good. However, if you're getting to that place where between the absorbers on the wall and the ceiling, you're getting to too much absorption, you can actually put a panel like a B that because of its filtering will absorb only low frequencies, and that actual membrane that's in the front, that little piece of wood they put on there, helps as a tympanic absorber or a membrane absorber to absorb more low frequencies, which is really what hits the front wall. Think of this, the loudspeakers that are radiating out to you, they're sending their mids and highs in that direction. What's going towards the wall is lower mids and lows. So that panel that's on the wall behind the speaker, if that was the wall behind the speaker, really wants to absorb lows. It's not going to do anything to the speaker sound at the high frequencies. However, if there's a lot of it, you'll sap out the high frequency energy out of the room. And I think, like we've talked plenty on all these sessions, you don't want too much of that. So sometimes on rooms we actually use panels like those that are a big thick chunk of some type of absorptive material with a wood plate on it that's perforated just to let the mids and lows in and reflect highs. Gotcha.
And some of those are pretty decorative too. I know I was looking at some from Gick Acoustics, for example. Yeah.
Yeah, in the Sonatus line, we have about 4 or 5 different patterns in 4 or 5 different colors. So there's a lot of different choices, and there's a lot of other manufacturers that are doing those because they are decorative, and in fact, because they don't over-absorb the highs, they are useful in the rooms we're all working in.
Right. Now, last question I have for you.
Sorry, I don't want to jump in. So, Anthony, when you're designing the acoustical treatments in these rooms that you do, and you design your initial deployment of acoustic treatments and diffusers, is there a tweaking or a process, and maybe adding a little bit here and adding a little bit there once they're deployed in the room and measurements are taken, or that usually all done up front?
Yes, that's a great question. So you asked me how many projects a year do we do? Most of the projects we do we have to engineer them. It all has to be modeled, and it's going to get built like what the plan says. And I'll show you some plans on another session. Mm-hmm. And there's no tweaking. There's it is what it is. It's kind of like you're building a plane, you're building a bridge. You got to build it. You can't experiment. It's like, I don't know, I want this bridge a little. No, dude, you got to come up with a plan. So I'd say time it is what it is, and we spend a lot of time up front modeling with all kinds of different tools what's actually going to sound like, including being able to analyze the sound. There's some really cool computer programs. You can build a room, you can put the panels, you can put the speakers, and you can actually listen to, in binaural hearing, through what's called auralization, you can listen to what's happening, you can move yourself around. Very cool. And that's really quick because you don't actually have to take a diffuser off the wall and move it. You can actually just, take the mouse, move the diffuser, listen. That's very cool. And then 20% of the time, we actually are working on high-end listening rooms where we can try to move things. We can do measurements. The reality is, when you get to that point, this tool, not these automotive headsets, but that thing that's inside there, the ear canal and the brain, that's going to tell you what it sounds like. I am finding that there are not very conclusive acoustical measurement tools that tell you, aha, that's going to sound great. It is some good rules of thumb, and then you go in the room, you move things around if you can. You try that. You try symmetrical, you try asymmetrical, which is where we found close to 17 years ago that just the slight asymmetry tended better for a good combination of spaciousness and good clean imaging. And fortunately, I'll be honest, only about 20% of my practice gives me the opportunity, because there is not a big interior design component, around. So this particular room, I was here about a month ago before the fabric went up. We did some listening, we did some measuring, we did some stuff, actually adjusted things a little bit, but that's actually not that common, fortunately, in the real world.
Right.
Do you think binaural mics might be a game changer in the future for better analyzing rooms?
Yes, Yes, thank you for bringing that up. So there's a whole new trend in these binaural mics, these really wacky looking things you can get from an interesting company in Asia that allow to get a three-dimensional mapping of what's going on. And so once we get the maps and we have enough listening comparison against those maps, and we go, okay, well, that means this is going to sound good. Everything I just said about measurements not really telling you is going to go away. We'll get to a point where you can actually really measure the stuff and end up with conclusive results.
That could be a whole topic of another video right there. Just binaural recordings, all that stuff. It's really cool.
My chief engineer, Manny Lakaruba, that designs all our speakers, helps design the rooms and stuff. He keeps bugging me. I want to get one of those mics. I want to get a few of them. Oh my God, it would be so amazing. He's like salivating over it.
So I'm going to let you in on a little secret. We actually have one, Matthew Pose, and we're going to be talking about that in the coming weeks. So just wait. We're going to be doing some cool stuff.
If I send you a box of really nice Belgian chocolates, will you...
You have to come down to Florida when we have this whole room set up, and you could, because we're looking at doing stuff with the binaural mic and seeing, if we can make more accurate room measurements, and that's why I brought that up.
Right.
So, yeah, we got to. And we'll have plenty of chocolate if you come down, Anthony. We'll have plenty of chocolate for you. I promise you.
Great, fantastic.
All right, guys, I think we're going to wrap this up for now. It's been our hour, and I know you got to get back to doing your calibration.
Yep.
Anthony, I always appreciate you coming here. This is an awesome thing that we're doing once a week for our audience. I can't tell you enough. And Don, you bring excellent perspective as well as a professional integrator, one of the best in the industry, I might add. That's why I chose you to do my house.
Shucks.
We got one last super chat. I'm a large format printer and looking to print acoustical paneling. Do you have any recommendations on where to start?
Yes, indeed. That's a great question. So we've been messing with this for, I'm going to say, about 15 years. The right way to print, regular printing where you're applying ink or inkjet or regular paints is going to occlude the fabric, and sound won't get through the fabric to get to whatever's behind it. Whether it's absorption or diffusion. Dye sublimation, which has now become way more plentiful, is the right way to do it. That's if you're a printer, you know what I'm talking about. But the idea of dye sublimation is you start with a sort of a semi-solid pasty ink, and you put it on a paper in reverse form, and you press it with heat to the fabric you're wanting to print. And superheated, super pressed, and the semi-solid ink sputters out into gaseous form. The sublimation, it jumps from solid. It does not stop at liquid; goes right to gas, and so it actually dyes the fabric. And so, if you could look at it with a microscope, you'd see that there's not a layer of ink. Instead, it's the strands, like the little pieces of the fabric, are actually colored, and that means it's not occluding. It's still porous. The sound to the fabric. You want to start with an acoustically transparent fabric, and there's some that the weave is too tight and the materials don't let the sound through. But if you start with either a polypoplin or some of the other more acoustically transparent fabrics out there, which we can go offline and chat about what are some good choices. And
awesome.
you print with dye sublimation, and you control your process, and you get the colors right. All that you can produce some really gorgeous looking things.
Awesome. All right, I think we're going to wrap it up, guys. Awesome info we got here. Next week, same time, Thursday, 11 p.m. I think we're going to get deep into bass traps. I know everybody like me, I'm a bass head myself, so that'll be a really interesting one. So everybody bring your subwoofer questions and bring your bass trap questions, because that's what we're going to be focusing on. Again, thank you, Anthony. Thank you, Don.
Thank you, Gene. Thank you, Don.
Appreciate it. Love you guys.
Okay.
Guys, don't forget to hit that bell notification. That way you know when these kind of live streams are happening. We're going to have another one this Saturday with Matthew Pose, probably. I think it's going to happen. And we're going to be talking about binaural recordings. So that's going to be another interesting one. Don't forget to hit the subscribe button, bell notification. Don't forget about our Patreon channel at patreon.com/audioholics. And until next time, my friends, keep listening.